right, everybody, welcome to Today in Space. I am your host, as always, Alex Giarfanos, and we're here on episode 351 to talk about another Boeing Starliner update. The crew flight test is still underway, and we had a new update on July 10th from the NASA team and the Boeing team, and this is where the press was able to ask questions afterwards. Before that, about an hour and a half before, both astronauts, Suni Williams and Butch Wilmore, had done a press conference from Earth to the space station about Starliner and what their thoughts were about Starliner, expressing confidence. And then the NASA and Boeing teams shared their update. What we've got here are some of the best questions, and I think I'll say revealing in that it just gives you a good insight into how the people who are in charge of this, or at the very least, are communicating to the public about what they're doing in these highly technical situations. I think it's a really good breakdown if you're looking to really understand what's going on here. And more importantly, they answer such great questions about the specific problems. And so we're going to dive into all of that. So before we get started, thank you for joining us. As always, we want to make sure that we're covering all the most interesting stuff about space on this All Things Space Science podcast. So make sure to reach out to us on social media, on Today in Space on TikTok, Today in Space Pod on Instagram and X/Twitter, and Today in Space Podcast on Facebook. And you can always email us at todayinspacepodcast@gmail.com. So make sure to do that. This is clearly a topic that people are very much into. It's one of our more popular YouTube videos, the full episodes. It's definitely getting more downloads in the first week than some of the other stuff. So that's why we wanted to dive into that. Last week was kind of my big picture look about what this mission means. So if you didn't hear that episode or watch that episode, go back to episode 350, and I talk about my thoughts about the worst case scenario, the idea that, the commercial crew program is the whole reason that we did it was to have 2 human-rated spacecraft, and we already have Dragon spacecraft, the Crew Dragon from SpaceX, that's already had multiple missions, right? We have another spacecraft. So last week was all about the miscommunication or misinformation that was going around that Boeing Starliner was stranded on the space station. That's pretty sensational, and these questions that got answered actually tell you a lot about the mission, what they would do in different scenarios, and how Boeing is thinking about the spacecraft and the risk involved. So this is the perfect way to jump back into what's going on and really see behind the scenes, and probably something that you're not seeing reported on, although we had some really fantastic questions from these space reporters that I follow. A few of them I had heard from before, and a few I'm going to start following because they asked very poignant, solid questions and really got the teams to open up and share more. So, without further ado, let's talk about the first question here, and it's a great one because it actually is the first time that I've heard the Boeing and NASA teams really talk about the fact that the Crew Dragon is ultimately the backup. But as you'll hear, these engineers and leaders are, science is very interesting. In science, I think it's more scientific to say I don't know and to express what you do know and the questions that you're looking to answer and how you're going to do that. I think that is scientific. There's also the approach about sounding confident and expressing confidence. I that's why I really like these questions, because it got them to dig deeper, other than saying this is a great test, this is, we're very confident and stuff like that. They did a they answered the questions. So let's start with this first one, a really good one, and then we're just going to run through everything. So thanks for joining us, folks. Let's dive into the Boeing Starliner CFT update from July 10th, 2024 from NASA and Boeing.
Thank you, Mark. Our next question from Micah Maidenberg at Wall Street Journal. Go ahead, Micah.
Hey, good afternoon. So Steve and Mark, we've been going over the work on the thrusters and the helium leaks and how the team has been reacting to those issues. I guess my question is, at some point, do you have to potentially stop reacting to those issues and shift to potentially using a different vehicle, for the return? I mean, is there some sort of preset trigger or red line that you would potentially cross that would sort of mandate or prompt such, that kind of a shift? Thanks.
I can start and then see what Mark has to add. I think the testing at White Sands is hugely important as part of that. Taking the data that we learned from White Sands and looking at the thruster and inspecting it physically, just to make sure that with all these pulses and all the heat we're putting into it, that it doesn't cause any damage to the thruster at all. The data from the flight suggests that the thrusters, except for the one thruster that did not recover, are operating just fine. I think that physical inspection is probably the most important thing that's going to happen over the next week or so. And then, after that, we've talked about the beautiful thing about commercial crew program is that we have two vehicles, two different systems that we could use to return crew. And so we have a little bit more time to go through the data and then make a decision as to whether we need to do anything different. But the prime option today is to return Butch and Sonny on Starliner. Right now, we don't see any reason that that wouldn't be the case. Again, this White Sands testing is probably one of the key things to look at the thrusters and make sure that we all the engineering data suggests that the thruster is performing well and has not sustained any damage in flight. In fact, the thrusters have been fired. Even the one thruster that was producing very low thrust, we're not going to use anymore. It was fired 270 times on docking day. One of the thrusters was fired another 450 times on docking day. And so I'll turn it over to Mark and see if he has anything to add.
I think the way you kind of concluded there was where I'm at. Plans are to bring the crew home on Starliner. We see no reason why that should be changed. We've got good hardware. We're trying to add to the engineering database of, so that we can bring good flight rationale together to our senior mission management team and provide more information so that we can, again, fix these problems once and for all.
So there you have it, a great question from Micah and some interesting insight into what Boeing is looking at, and just saying it out loud that ultimately, if for some reason there is enough of a reason not to send the astronauts home, especially, even not finding a good answer on the thrusters, or not being able to replicate that. What if? And they answered it. So the Crew Dragon is indeed an option, however far down NASA decides in the process that should be. Now, as far as that one thruster, it's very interesting, right? So this thruster, the single thruster that they're talking about, I believe there was multiple that were deselected, as it were. But the issue here is the unexpected heat and temperature from the way that it was pulsing and why it was disabled during flight. So that obviously on a return flight where you're going to have to hit the atmosphere, any unexpected heat up could cause any kind of difference as this spacecraft goes back for splashdown after, shedding off the the energy of going 17,500 miles an hour at the space station, which is the speed that it orbits at, roughly. It changes from time to time. But, that is ultimately the question here. Now, we're going to find out more about what their plans are for that thruster on the return trip, especially if there is an emergency situation. But we'll get to that later on one of the other questions. But my take on this is that they are acknowledging the fact that there is another spacecraft, so there's no reason to make harsh or rash decisions. So that's good. And then we heard more of the just expressing confidence, kind of thumping of the chest of, we're confident in this spacecraft. Now, that is a choice on how to communicate science, and hey, that is what it is. It'll be interesting to see what the White Sands testing will do, but this also tells us that the spacecraft could spend, at the very least, up to that 90-day mark, which would be the next time when those batteries are reserved. So if there isn't conclusive tests from this thruster return, then the decision comes down to, is it what other testing can they do? So we'll see. But it seems like that's going to take more time, especially since Hurricane Beryl did seem to affect a lot of the work, especially in Houston, right? So those folks didn't have as much of a chance and as many opportunities to get this done. I know there's a bunch of folks, especially the VFAM, like H-Town and Ben Kind and Whiskey Jack and all those folks down there, and anyone that I forgot. Luckily, they're safe. Power's coming back on finally. But that's also the people that were working on this mission, right? So this, it's going to take longer now. So we're expecting more, but a really good question from Micah and really good answers and insight into Boeing and NASA. So let's jump into the next one.
Thank you both. Next is going to be Chris Davenport at the Washington Post. Go ahead, Chris.
Thanks, Steve. Regarding the flight profile, the RCS thrusters were obviously very important for docking. We just heard Butch talk about how precise it had to be, but I just sort of wonder, how dependent are you on the RCSs for the return trip? I wonder if there's any way to characterize how much they'd be firing on the return as opposed to on the uphill portion of it, and what that difference is, especially if the overheating is an issue. Thanks.
The biggest, great question. The biggest demand for those aft thrusters for the remainder of the flight is at the deorbit burn time frame, and it's really not. Those thrusters aren't used to provide the thrust for the deorbit burn. Those are the OMACs. We'll fire 4 OMAC thrusters out of the 12 that we have. We know all 12 OMACs are working just fine, and we know that the propellant feed system for all the OMACs are working just fine. But the biggest demand is several hundred pulses during that deorbit burn to maintain the OMACs fire to provide the delta V for the deorbit maneuver to bring the vehicle back into the atmosphere, and then the RCS thrusters fired associated with those OMAC firings to just hold the orientation of the spacecraft as that deorbit burn is executed. And so that's the biggest demand coming up for those thrusters.
All right, Chris Davenport with a great question and a great answer. We get more into what thruster is involved that they're worried about and the deorbit, right? Going from the space station, cutting down the speed, and then splashing down so these astronauts come home safely. That's a huge part of it, right? This aft thruster is it's like I guess the good analogy is, this is like the micro muscles, like the balancing muscles, right? The really tiny, fast twitch thing that really helps you balance. So these thrusters help the spacecraft balance itself and orient itself in the right direction so that the heat shield's facing the right way and it's not moving all around, right? Because it is blasting through particles, creating plasma from all the heat and pressure against the spacecraft shedding that 17,500 miles per hour, right? And the so it's not involved in the slowing down of the spacecraft, which is what they were talking about. The delta V, very important in space. It is, in fact, almost everything. Delta V is how you plan for a mission, and it's how much of the fuel and the velocity that you're able to change at one time. That delta V is your fuel. It's how you're able to change the wild speeds that your spacecraft is going, and you need to account for it before you even send the spacecraft up there. You've got to have enough fuel. You've got to know what moves you're making. And for the thruster, for this specific aft thruster, what they were saying was if this thruster has to pulse, which would be short bursts, right, in order to like reorient the spacecraft in a specific direction, if it does more than the flight profile they're expecting, it overheats. So with this thruster, which apparently has a redundant thruster, they saw it overreact and overheat. And so as long as there's a redundant thruster, then that thruster should be fine. But this testing will help them figure out, will the next one do the same thing, right? And if it does, what does it mean for the spacecraft and the return home? So really interesting stuff. A good question. I just wanted to break that down real quick in case anyone was lost, but some really good information on that one. So let's jump back in.
Thank you. And next, Gina Sunseri at ABC News. Go ahead, Gina.
Yes. Moving on to when they undock, what tests do you have for the crew for Starliner on its flight home?
Go ahead, Mark.
So the nominal. There really are no tests that we have to run once we undock. We have a series of operational checkouts that we're currently going through to see whether or not we want to run those after we undock. But the majority of the work that has to be done after undocking is just nominal return.
And I would add to that, obviously the whole undock to landing and then recovery of Butch and Sunny are part of the test flight. So for this unique undock and deorbit landing sequence, the biggest change, obviously, from OFT2 was we have Butch and Sunny on board. So, I'm sure we'll learn a little bit about getting in the seats and the suits and all those sorts of things. But those are all nominally planned activities. There's no special test for those. And then, how the vehicle does relative to the heat load of the crew and comfort of the crew during deorbit landing. And then we'll have accelerometers on the seats to measure the acceleration during entry, the G loads, the Gs at landing, and so forth as part of the test flight. Those are all, I would say key parts of the test flight. But other than a couple of maneuvers that Mark talked about, the OCCs, which we're debating whether to do or not, the rest of the flight is really learning our first landing with crew.
So this one was more of a reporter question, by no means unintelligent. I don't think that the teams answering the question really understood the point of the question. To me, if I was going to answer that question, I would have talked about that this is a test flight and that the whole thing is a test, and that there are people on the ground that are going to be watching this in Houston, and they talk about what those teams are responsible for, talk about the different phases of the mission briefly, just give an overview and talk about the different things that are being constantly monitored, that or maybe the phases of the mission that are really important milestones in what they qualify this test to be a success. But what do I know? That at least would have been how I would have approached answering that question. So a good question from the reporters. And so let's jump into the next question.
Thank you. And next we're going to Lauren Grush at Bloomberg. Go ahead, Lauren.
Hi, thank you so much. So I'm wondering if you were to bring Starliner home right now in case of that emergency you were talking about, what would the thruster profile look like without the white sands testing being done? And I know this requires speculation, but can you give us an example of what you might learn from that downhill phase of testing that would change that profile? Would you turn off certain thrusters? Would you somehow limit the pulsing? Just curious how different it would be from the emergency scenario now.
And Steve, I'll try to give this a shot and see if you want to add something. So after undocking, if we were to have to do that today, we would just perform a nominal undocking and return. The propulsion system is highly redundant on each other. So if there was an issue with any one of the thrusters, the redundancy would take over and bring us safely home. Again, what we're trying to do with this testing is fill in some gaps because what the concern, what we're trying to do is understand if the thrusters are performing nominally, then we will be able to undock and just return nominally. If the thrusters were somehow damaged, then what would we do differently? We don't believe that we have damaged thrusters, but again, we want to fill in the blanks and run this test to assure ourselves of that.
Yeah, I think Mark said it well. The only plan we would have right now is there's one thruster that was producing very low thrust that we would disable for the rest of the flight, and that's going to be the plan for the nominal into mission whenever we have the nominal deorbit, and that's the plan for undock right now. That would be the B1A3 thruster. We would not have that thruster available, and with the OMAX system that we have in place for the deorbit burn, that should happen nominally. We have 12 good OMAX, and then based on the data, engineering data we've collected during the flight, we expect that the thrusters would perform just fine with the number of pulses that they have on them. We have run engineering analysis and simulations with many of those thrusters failed just to understand what that would do to the deorbit burn. And the deorbit burn sequence is very robust to any kind of thruster failure. So even if some of those thrusters were to fail off like they did on docking, the deorbit burn would be successful and the entry would be nominal.
I'd add one more thing that probably should have mentioned in my answer is that, we do have a lot of confidence in the thrusters as they are today. If you remember, shortly after we docked, we did a docked hot fire test where we fired 4 of those thrusters, and they all came back to either a nominal or very near nominal performance. So that's what gives us a lot of confidence that we have a good set of thrusters right now. With the extra time, though, let's go run this test and let's go try to replicate what we saw in flight and assure ourselves of that.
So there is the answer, and the last question that we're gonna go through. But another really good question from the media. I was really happy to hear this, and I like how intelligent and spot on the questions are. Now, as far as the answers, I think they got caught in kind of a logical loop for themselves. And I don't think repeating the word redundancy and confidence is actually increasing confidence. And I thought the question was great, but they talk about all the redundancies, but what does that redundancy mean, right? Is there a backup thruster to that thruster? So if they shut off that thruster, which is good to know that they would do that, then what happens if that other thruster has the same issue? If they shut that off, do the other thrusters adjust to that missing thruster? And then what does that profile of how that has to change? I'm assuming the system would do that automatically to keep the navigation control of the attitude of the spacecraft, but how does that affect? It seems like more pulses, which I would assume would be happen to compensate. Isn't that causing the same problem that this thruster that's being tested in white sands would happen? And they basically said that they actually don't think it's a problem. Like, they basically said that they would, if they were forced to leave today, they would just deactivate the thruster and send them home. So then it begs the question, why NASA's having them stay longer? I don't believe it's purely a scientific adventure. It's not the final frontier, Star Trek, we're just doing science and exploration. There's a reason it's staying longer, and I'm not trying to be conspiratorial, but I don't think that they did a fantastic job answering that question. Now, look, I, as an engineer, do end up on the customer-facing side of things, right? I work in tech. It's a product. There aren't human lives involved, but I do communicate those complex things in my day job as well. And there's a certain skill set to being the engineer, talking to the other person. A lot of engineers don't talk to people outside of the scope of their project. And a lot of times they don't want the engineer saying much because they're going to probably say too much, right? They're going to tell you all the ways that it could fail because they need to be well versed in that. But that's not great for discussing this to the public. Now, I think that the big question is how critical is this to their return home? Now, when we're talking about these thrusters not being involved in the delta V of the major slowing down of the spacecraft, and most of the movement that the spacecraft is going to make, but the balance of the spacecraft is what this thruster that had issues is all about. And if the spacecraft becomes unbalanced as it goes through the atmosphere, especially if they shut off that one thruster, we know it has a redundant thruster, but what is the new risk now with only having one thruster? I'm assuming there's only one. If there's only one of these thrusters and now there isn't a redundancy to that thruster, this is where the testing becomes really important, especially if it was being disabled because it was heating up too much. If that happens during the reentry, what things could happen? What different ways will the thrusters try and compensate for the one scenario where this redundant spacecraft thruster doesn't work or the software decides to turn it off? That, I think, is so far the crux of it, and I think the media did a great job sending the questions to the folks in charge and communicating this to the public, and I thought the people answering the questions did a great job. Now, I think there was a lot of chest beating, but that, again, that's just my feeling to my side of the approach of doing this, and it's not my job. So, but again, I thought they did a great job, and I think we learned a lot about this. So that's the latest Boeing Starliner commercial crew flight test for the commercial crew program, which is America's ability to have 2 human-rated spacecraft to bring our astronauts to the space station from American soil in American-made spacecraft. Instead of paying the Russians $56 million on average per seat for an astronaut on board one of the Soyuz systems. Especially now with the conflict with Russia, this is something that is really good that we planned ahead for this, because the space station might not have had people on it if Russia decided they weren't sending astronauts anymore because of the conflict, and we didn't have a way to send our own. So having Crew Dragon already qualified and 8 missions into 8 operational missions and 1 test flight mission in their history and experience of sending astronauts to the space station, this is Starliner's first test flight with human beings. And so we're going to find out if they're going to qualify the spacecraft after this mission, or if they might have to do another one to get their final certification so that we have 2 operational spacecraft. And the most important thing, having another as a backup for whatever reason, if a spacecraft is unfit to return, there is a backup. There is a redundancy. So that's it, folks. Thank you for joining us. We'd love to know what you think about it. Hit us up. Email us at todayinspacepodcast@gmail.com, and hit us up on social media, Today in Space on TikTok, Today in Space Pod on Instagram, and Twitter/X, Today in Space Podcast on Facebook. Have a great week, everybody. Spread love and spread science, and we'll see you next time for another episode of Today in Space.